Hello, thank you so much for being here. Welcome to the Azure Programmable Connectivity session. My name is Ricardo Villarreal. I am a product manager in Azure for Operators. And today we're going to be talking about the future of connectivity. We're going to be talking about this product that we are building. We are currently at a private preview stage. So let me first tell you about how applications are evolving. Applications are evolving into a paradigm that we called modern connected applications. Basically, what is happening is that applications, they are highly distributed these times. They can be running on many different places. They can be running on a private network, on a private MEC. They can be running on public network. They can be using a public MEC. They can be running, obviously, on cloud regions, on public clouds, or even on the space, right? They can be using space compute. Now, sometimes it's not even the whole application. Sometimes it's just components of these applications. They are running in different places. They are distributed like that. So applications, they need high performance networks. They need networks that can provide low latency. So they demand a lot from the networks. So basically what these applications are doing is they're becoming network aware. They're learning how to talk to the network. They are becoming network intelligent. So let me tell you the vision that we have for programmable connectivity and for our product. So the vision is, we believe there is an opportunity to make a better connection between these applications, the modern connected applications, and the networks that they use. This basically means making a better connection between operators and the developers. The operators, they are creating all of these technologies, these network technologies, that can provide new capabilities or enhanced capabilities to the applications. But the developers need an easy way to access these capabilities. They need an interface that they can use easily, an interface that works like interfaces they are used to when they are developing applications. So that's where we sit. Azure Programmable Connectivity sits in the middle to make that connection. So let me show you the architecture of the product. At the top is the modern connected applications that I just mentioned. These applications that you see on the screen are actual examples of applications we have encountered that make a good use of these new network capabilities. At the bottom are the networks. They are the network operators. They are the ones building these network capabilities. These network capabilities are being exposed with network APIs. And what we do basically two things. We sit in the middle and we do two things. We unify and we abstract. When I say we unify, we mean we consume the network APIs, the network capabilities from many different networks, but we only present one interface to the developer. So the developer only has to write code once. When I say we abstract, is basically we present these network capabilities in a friendly manner to the developer, in a way that developers are used to consume cloud services. We give the whole Azure experience when they are consuming these capabilities. So now, to make this thing tangible, let me actually give you an example. We've been working with Halo in partnership also with T-Mobile. Halo is a company that what they do is they rent electric cars. But they do it in a very interesting way. You can book an electric car and the car gets to you. It's driven to you, but remotely. There is a person sitting in a desk driving the car, and so they need a great connection. They need low latency. They need a low jitter in their connection. But they don't need it all the time. They only need it when they are in a crowded place, when there are many devices contending for the traffic space in that place. So what they do is they make an API call when they're in a crowded place. They activate a quality on demand network API that improves the latency. It lowers the latency, it improves the jitter, it lowers the jitter, and then they can drive, they can have a smooth drive. As soon as they leave the crowded place, they make another API call, and they turn off the quality on demand. They don't need it all the time. With that, let me actually introduce you to one of our partners. I want to introduce you to Chema Alonso. He is the Chief Digital Officer of Telefónica, and he's going to talk to us about what the industry is doing in this space. Thank you so much.
Hi, this is Chema Alonso, Chief Digital Officer of Telefónica, and I'm pleased to be here today to talk about Open Gateway, which is a global initiative that all the telco sector is creating together with one single vision: to create networks developer ready. The idea is to configure and to construct new network capabilities that allows developer to configure every single aspect of connectivity in every single digital service using APIs. And that API should be a standard. Because of that, we have a project from GSMA, which is the Global Industry Initiative, called Camara, which is standardizing all these APIs. In our sector, we see that in the future, digital services are going to require much more from the network, much more from computing power, and much more from data. So all the investment that we are doing in the future networks to be the networks that developers need to create the future digital service needs to have three different aspects. First one, we need to deploy low latency technologies. It means that we need to take fiber to the home and fiber to the room, which is something that we are proudly doing in Spain nowadays. Secondly, we need to deploy 5G standalone technologies. These new mobile networks are going to allow us to create drone highways, completely secure, autonomous car streets that are secure using network slicing, etc. But also at home, we need to deploy new Wi-Fi capabilities, Wi-Fi 6 and Wi-Fi 7, to accomplish all the needs that the new smart homes are requiring for us. On the other hand, we see that computing power on the edge of the network is going to be a must in the future of the digital services. So we are creating our network deployment thinking on what is the edge strategy that we need to have, what are the computing capabilities that we need to put in the antenna, etc. And of course, if we are going to deploy new networks, which is something completely new that requires a lot of capex, a lot of money that should be invested in the countries, and we are going to deploy edge capabilities in the network, we need to make sure that all of these capabilities are developer ready. So we are working in networks that are taking advantage of the cloud capabilities, that are fully softwareized, that are fully compliant with APIs, allowing developers to configure every capability just using line of codes. And because of that, we have a different view from the past. We are thinking on developers right now instead of thinking in IT people. In the past, we were configuring our capabilities, thinking on IT people connecting to console, configuring ports or IP address or whatever. And right now, we are thinking on different way. We need to make sure that all of our capabilities are available and configurable in one single line of code. We need to work with the developer community to discover how that API should be for the whole sector. We are not creating APIs for one telco or another telco. We are creating APIs that are standardized for the whole sector under the umbrella of the GSMA and the program that we call Camara. We need to make sure that all of those capabilities in the network are available in real time, on demand, and all of them are smart. So they are creating all capabilities, not requiring from the developers to know and to configure every single detail of the network as today they need to do. And it's only not for communication. That, of course, is one important part for for our industry. Communication platform as a service is something that we've been working in the past. And of course, private networks, network slicing capabilities are going to be part of this strategy, but we are having a broader vision of these capabilities. We have identity and fraud APIs using phone number, using IP address, using location of the devices on the network, etc. We are also providing capabilities like carrier billing, that today is something that we are providing for companies, but only big corporations that are big enough to deal with our complexity are taking advantage of these capabilities, and we want to standardize that. Of course, SMS, RCS, and all that messaging communication, and of course, all related to computing on the edge is part of the vision that we have today for this Open Gateway initiative. And that's all. If you want to test these capabilities, we are going to be part of the Azure connectivity, programmable connectivity. And of course, we already launched an early adopter program to help you if you want to test these capabilities in your digital services. Thank you very much.
Hi, I'm Landon Cox. I'm in the Azure for Operators Office of the CTO. And today I'm going to talk to you about Azure Programmable Connectivity. So Azure Programmable Connectivity, or APC, is designed to make it easy to access the programmability of all kinds of networks. And as Shema and Ricardo mentioned, our first network partners are mobile network operators, but APC is designed for all kinds of programmable networks, including private networks, wired networks, and even satellite networks. And Open Gateway and Camara are a great start, and we believe that other networks are going to embrace programmability in the very near future. Now, APC provides an abstraction layer on top of all the APIs that networks are offering, and it offers 4 key features through its abstraction layer. So first, APC manages developers' credentials. So APC will handle whatever authentication or consent protocol is required to access networks' APIs. Second, APC allows developers to discover what is happening on a client's network. So for example, you can discover which servers are on a client's network, and then what the expected performance between a client and those servers might be. Third, APC allows developers to configure the connectivity within a network. So for example, a developer may want to enable quality of service between a client and a server, such as a Halo car and its remote pilot, or a developer may want to ask the network to create a firewall between a client and a server for security or regulatory compliance purposes. And finally, APC allows developers to monitor the status of the network. So a developer can register a callback to be notified when network conditions change or a device's status change. So now let's walk through a simple video analytics example to see how a developer can use APC. So in this video analytics example, we have cameras deployed over a large geographic area. So maybe they're stationary, or maybe they're mobile in the case of a Halo car. These cameras are connected to multiple networks because they're over such a large geographic area. In this case, there's a Contoso network as well as another 5G network. And in addition, there are a number of compute sites that are close to these cameras. And the problem that we're facing is, how do we connect these cameras to the closest compute site? And then secondly, how do we ensure that the connectivity between the cameras and their assigned compute sites is reliable in the face of network congestion? Okay, so our solution uses APC to match cameras to clusters and then to enhance the connectivity between the cameras and clusters. So let's walk through this example. Okay, so when a camera comes online, the first thing that it's going to do is contact a global coordinator running in Azure. And this global coordinator is using APC to talk to the network. And so the coordinator is going to use APC to decide what is the closest cluster to this camera. And then it's going to make an assignment, and it's going to write that assignment into a global database. Now, each of the clusters is monitoring this database to look for new assignments. Okay? So in the next step, the application sees that it has a new assignment, and then it connects to the camera feed. Now, the final step is when the camera sees that it has a new connection, it's going to call to the global coordinator again, and it's going to ask the coordinator to use APC to configure the quality of service between itself and the public MEC. So now I'm going to show a demo of this use case running in Azure. Okay, so now I'm going to show you a demo of the use case that I had just discussed. And so we have all of these resources in Azure. You can see that we have one cluster in Atlanta, we have another cluster in the West US. And for this demo, we don't have a real network, so we're using a mock Microsoft network that we can talk to. And to kick off the demo, I'm going to start one of my cameras. And then I'm going to look into the global database where all the assignments are made. You'll see right now that they're empty. We can look at the Atlanta cluster on all the services, and we can look at the West US cluster and all the services. But I really want to go to the coordinator since that's where APC comes into play. And so I'm going to look at the output for the coordinator, loaded into the log stream here. And so we've got our coordinator code over on the right. And there are really three things that I want to look at inside of the coordinator. So if you remember, the first thing the coordinator does is that when a camera comes online, it asks the coordinator to assign it to the closest edge. And so the coordinator uses APC to do this in two ways. The first is that it asks the network to list all of the edges that are on the same network as the camera. So that's this call here, get edges. And then if you go into the get closest edge, it's going to take those edges, it's going to iterate over them. And then for each edge, it is going to get the properties between the camera and the edge. So in particular, we're interested in the latency between the camera and the edge. So when the camera comes online, what we should see is the output. And here we see the discovered edges between the camera and the different clusters. So we have, you'll see West US, you'll see Atlanta, and then we got the latencies between the clusters and the cameras, and we selected the closest one, which in this case was West US. Okay, so if we go back into our global database and look at the West US entry, now we'll see a new entry. Okay, so this new entry provides all of the details that are needed to connect to that camera feed. And so if we go back to our output, the other thing that we'll see once we've made the assignment is we see a request to set the quality of service between the camera and the cluster. And so that's done here, whereas previously when we were making an assignment, we did a get properties through APC. When we set the QoS, we make a set properties call right here. And so here we're just requesting that the network make the latency between the camera and the cluster as low as possible. And so one of the things I want you to notice about this coordinator code is that there's nothing network specific here. We don't actually know anything about which network the client is on. So this code doesn't have to change. As you add new networks or deploy things on different networks, this code, the APC code, will stay the same. Okay. So now finally, we can go back to our West US cluster, and we can see what's happening with that camera feed. So if we go to the services for this cluster, we have an alerts UI. And so if we click on the alerts, what we should see is we should see processing this video feed, right? So the video is just a scene from a sidewalk, and the application is just looking for people in the camera feed. So all of this happens dynamically. Once the camera came online, it contacted the coordinator, and then the coordinator made an assignment, and then the cluster picked up the assignment, and then the camera configured the quality of service between itself and the cluster. So hopefully that gives you a good sense of how you can use APC in your own applications. Thank you for attending this Azure Programmable Connectivity build session. To learn more about APC, you can follow the links on the screen.